Good morning, everyone. Welcome to this morning's session. When we were first talking about demo theatre session titles, I wanted to talk about the local server as a component of the ArcGIS Runtime SDKs. And I suggested to product management that I wanted to call the session Advanced Mapping and Analysis with Local Server. The session title that came back from product management was Living La Vida Local Server. Unfortunately, there'll be no singing and dancing today. So actually, to give you some context for the session, I just wanted to talk a little bit about the local server itself, just so you understand where it fits in the architecture. So I'm talking about the local server. It's a component of the ArcGIS Runtime SDKs. There's actually a bundle of Arc objects inside the local server. So although we say there's no Arc object in the runtime, there is a bundle of Arc objects inside the local server, specifically built to be able to run on Windows and Linux, and also to support some nice features like Xcopy deployment. There's also Python, a Python environment included with the local server. What we have within the local server then is a series of local services that run on top of local server using those Arc objects, using Python, so a local map service, a local feature service, and a local geoprocessing service. All of those are exposed through a REST API interface. So that's essentially very much like a mini ArcGIS server, but running locally on your device, and interaction is handled entirely through the ArcGIS Runtime APIs. So working with the API, you'll both... Okay, can you hear me better now? Okay. So working with the ArcGIS Runtime APIs then, you're both a developer and also a mini server admin, if you like. You're working with the local server instance. You're responsible for starting and stopping services and determining their life cycle. And then the local server is available with the ArcGIS Runtime SDK for .NET, the ArcGIS Runtime SDK for Java, and for Qt. Some of these SDKs do support other platforms such as Android and iOS, but the local server is only available on Windows and Linux with these SDKs. Specifically today, I want to talk about local geoprocessing services, Python, and I'll be dealing entirely with the ArcGIS Runtime SDK for .NET. Unfortunately, Java and Qt didn't show up. So. Okay, so let's take a look at demo 1 then, elevation profile. So I've got a WPF application here. Oh.
What number are you? Doesn't say.
Doesn't say. I wonder if... Okay, so I've got a WPF application here built with the ArcGIS Runtime SDK for .NET. You can see our area of interest on the screen in the middle, and this application uses local server to generate an elevation profile. So if I draw a line from, I think it's Black Mountain over on the western edge of Joshua Tree there, over towards the San Jacinto area, then that line gets sent off to the local server. I'm running some Python code in the background, and then it's returning the elevation profile. I'm using a WPF charting control here just to show the elevation profile, but if we hover over the line, you'll see that I'm actually getting information about the distance along that line and also the altitude of the point at that location. So let's take a look at how I built that. Well, it was built in ArcMap. I started off with taking an extract of the world elevation service. I just wanted a small elevation set to perform this analysis. So I'm using a world elevation extract. And then I wrote a Python script. So using a Python editor of my choice, you can see it in Notepad here, but typically I like to use Visual Studio to write my Python scripts. It's actually a very simple script in this case. I'm importing a couple of Python namespaces, taking a couple of inputs, so I'm bringing in the line that's drawn by the user, and also an input raster data set. And then I'm determining a couple of output workspaces as well. So there's some optimizations you can make when working with the local server. One of those recommendations is if you're writing any intermediate data, or even then to use the in-memory workspace to avoid the overhead of writing to disk. I'm then calling two different geoprocessing tools, one within the 3D Analyst library to interpolate shape, so that's interpolating that line across the elevation terrain. And then I'm also using the linear referencing tool here called create routes, and that takes that line and then generates measure values along the line. So my interpolate shape tool gives me, breaks the line down into points with an elevation value at each point, and then the create routes tool generates a measure value at each of those points as well. And that's how I'm able to hover over the line and display the Z value and the M value at each of those locations. And then finally, the script just sets up an output parameter. It's a Python script, but I imported it into an ArcGIS toolbox here. So if I look at the properties of the toolbox, I can see the source is my Python script, and then also I had to define some parameters here. These parameters, the order of them need to match the parameters that I'm specifying in the Python script. So you could see that I had two input parameters. One was the input line, one was the input raster data set, and then the third parameter was actually the output parameter as well. And the way I define those, when each of these parameters is selected, there's a type property down here. So it's either an input or it's a derived property. So I've got two input properties here, and then finally the elevation profile is actually a derived output. Okay, so that means it's an output of my geoprocessing model. So having imported that script to a toolbox, if I open it up, the ArcGIS framework auto-generates the user interface for that. So it shows me that there are two inputs required, and again, I can draw the same line across the terrain there. Now, in this case, it's requesting an input raster because I thought for my geoprocessing script, I might want to be able to choose the input raster. In this case, I'll just browse for the raster data set that I've got within a file geodatabase on the disk here and execute that. And this Python script's now running within the ArcGIS desktop geoprocessing framework. We can see that it's executing at the moment. We get feedback. We get feedback within the results window here, and we can see that it succeeded. And if I look at the attribute table of the resulting line, you can see that the geometry type is a polyline with Z and M values. And those Z and M values were added by the interpolate shape and the create routes geoprocessing tools. And then it's the Z and M values that allow me to display that measure and altitude value in the client application. So that was demo one, building an elevation profile application with local server and the ArcGIS Runtime SDK for .NET. Now let's take a look at demo two, which is, I think, much more on the theme of living La Vida local server. I have to thank a chap called Martin O'Leary for this. He provided all of the Python scripts that I'm using in this demo theater. So again, I've got a WPF application here. I built it with the ArcGIS Runtime SDK for .NET. It's making a call to a local geoprocessing service that I've authored within Python and executing that in a separate process. And then ultimately what it's going to do is generate a fantasy map for my application. So while that's processing in the background, this whole thing started off when I saw a blog post or a Twitter post about the Uncharted Atlas. So Martin O'Leary has written a Twitter bot that generates a fantasy map every hour and posts that to Twitter. And I thought, oh, that's incredible, actually. That's a really interesting idea. He's using various different algorithms, fractal algorithms, and different Python libraries to generate random locations, random coastlines, and infill the terrain. From the Twitter post, I could navigate to information that he's written all about how this works. And I could see here that here's his messy Python generator code. So I contacted Martin and I said, I'd love to use your Python code within a demo theater at our Dev Summit. And he said, that's great. It's a little messy. I can't offer you any help, but it should work okay. So all of the Python code that he wrote to generate the map is within a GitHub repository here. So we can take a look at the Python code. The entry point is this generate Python script here, which takes in a few arguments and then ultimately executes the terrain generation and generates the fantasy map. If I switch back to my WPF application, while I was talking there, the local server has done its work, executed all of that Python code, and generated a map for a random location. No one's ever seen this map before. It's entirely new. So how did I build this application? How did I take that Python script that I found in a GitHub repo and get that to work within local server? Well, one of the things that I considered when thinking about it is it even going to run in ArcGIS at all? I don't even know what additional Python libraries might be required. Fortunately, I discovered that someone had submitted a pull request to the repo, and they were adding a requirements file that told me all of the different Python site packages that are required to execute these Python scripts. So that was incredibly useful. What that allowed me to do was navigate to my Python environment on my machine here, installed with ArcGIS 10.4. Take a look inside the site packages folder, and then I could match up the Python libraries that were required by the Python scripts to the libraries that I already had installed. So I identified some gaps here within the Python libraries. Not all of them are installed by ArcGIS. There's one of them particularly called Noise here is responsible for the fractal algorithms that generate a lot of that terrain and infill the map. So that's definitely not included with ArcGIS, but we can add it to the ArcGIS Python environment and then make use of that. So if I take a look at my Python environments, I said typically I like to write my Python code within Visual Studio. Visual Studio also allows me to manage the Python environment. So it picked up the Python 2.7 environment from my ArcGIS 10.4 installation. If I switch to the pip option here, I can see all of the libraries that are installed. So if I search, for example, for lorem ipsum, if I search for lorem ipsum, it actually shows that it's already installed in my environment because I've already installed that in preparation for the demo. One of the nice things about this, though, is that I could just easily click that link to go out to the Python library online, bring down the package, and install into my ArcGIS Python environment. So for the three packages that weren't installed with ArcGIS that I needed, they were Noise, Cycler, and lorem ipsum. So lorem ipsum is responsible for generating the text that you see that makes up the place names. Then I install those packages into my ArcGIS environment. And that then means I can actually run that within ArcGIS. So I've got the Python scripts running locally here. What I need to do is just create a new toolbox. We'll call this demo 2. And you'll start to see the process that I went through for the previous demo about importing my Python script. I'm going to... Okay, I'll try to I'll hold the microphone much closer. I don't have someone standing behind me, unfortunately, like they do on the main stage. Okay, so when importing the Python script into my toolbox, one of the options that I'm going to choose here is to store relative path names instead of absolute paths. That just means it will locate the resources that are referenced by this script relative to the folder that it's running in. The next option, I need to browse for the Python script, and you can see here the folder of scripts that I've got contains all of those scripts from the GitHub repo, including a couple of extra files as well, description.grammar and frame.txt. These are just additional resource files. I've really got no idea what those do in this context, but I know that they're required for the Python script. There's the generate Python script, which was really my entry point, as I talked about from the GitHub repo. And then the one thing that I need to do in this case, I'm not defining any input parameters for this script. It's just randomly and auto-generating those maps. But one thing that I do want to do is define an output map. And that needs to be of type raster layer, or raster dataset in this case. And I'll as I talked about in the first demo, I just need to change the input type to be derived. So having imported that script then, I can right-click and edit that. Okay, like I said, I would edit within Visual Studio, but if I double-click, again, it's auto-generating the user interface, and if I click OK to execute that, that's now running that Python script within the ArcGIS environment. So ultimately, like I said, we want to execute this within local server. Right now, it's running it within ArcGIS. So let's take a look while that's running in the background. Okay, that error is not unexpected in this case. Let's just restart. Let's just restart ArcMap here. And I've talked about how I went to the GitHub repo, downloaded those scripts, installed the Python packages into my ArcGIS environment. I then added the script to a toolbox, ran the script within ArcMap. The process that we go through there allows me to create a geoprocessing package from that script. And then I work with that geoprocessing package within Visual Studio via the ArcGIS Runtime SDK for .NET. And we can see here the code that I'm using to start and execute this geoprocessing package. So I create a local geoprocessing service. That's where I said you are effectively, as a developer, also a mini server admin when working with a local server. So it's using relative pathing system to navigate to the fantasy maps GPK that I create within ArcMap and start the service. It creates a new geoprocessing task based on the URL that it gets back from the service. And then when I click the button to generate the map, it creates a geoprocessing job to handle the specific execution of that service. And then I simply, in Visual Studio, await the result of the processing. So a couple of things to talk about here in terms of how did I work with local server, and how did I get that Python script to actually run in local server? Well, I'm referencing a couple of NuGet packages here. I'm referencing the Esri ArcGIS Runtime WPF NuGet package, and also the Esri ArcGIS Runtime Local Services NuGet package as well. So those allow me to work with the WPF API, and then also to work with local services. That local services NuGet package will actually build a deployment for me based on this deployment file that I've got in my solution here. So if we open that up, we can see here that I've enabled deployment of the local server itself. I've enabled deployment of geoprocessing, and also enabled deployment of Python scripting as well. So those are pieces of the local server that will be built when I build my solution and deployed to a folder in my output folder for my project. So if we take a look at the bin folder here, we can see that there's, in my debug local server folder, that deployment's been built for me by referencing that manifest and then building my solution. You're only seeing a 32 folder here. That's a 32-bit x86 architecture, because by default, my WPF project has a checkbox which is prefer 32-bit. So we build the NuGet package and the intelligence in the build task to figure out what architecture your solution's based on, and then it will deploy the right components. So although I'm set to any CPU here in Visual Studio, if I take a look at the project properties here, we can see that my build architecture is any CPU, and it's still prefer 32-bit. That's the default option in Visual Studio for WPF projects. So that's something to be aware of if you want to build 64-bit applications. But the other thing I did in here to actually include those site packages, the additional site packages within my Python install, was to add as content from my ArcGIS Python environment the lorem ipsum Python scripts, the noise site package, and also cycler as well. And if I turn on show all files, you'll actually see the entire deployment there. So what I've done is browse into my deployment and then add the content. So you can see the local server, you can see all of the DLLs that make up local server there being deployed under my output folder, and then the other site packages as well that are required to run this tool. And then running the application simply involves executing the geoprocessing service that I created from that geoprocessing package. So very quickly, the code here. I talked about how I created a new geoprocessing task, created a new geoprocessing job. Once that returns, then I'm getting the output. So I know that the output is called map. I need to download, although it's running as a local service, what it gives me back is a URL or a URI to a raster dataset hosted by the local server web server. So I just need to download that to a location that I can reference from our raster layer within the API, and then just add that to the operational layers of my map. And that's how we see the map within the WPF application. So in summary then, that was a couple of demos of using the ArcGIS Runtime with local server and Python. It includes a really powerful set of tools for analysis and data management. There are many geoprocessing tools included with local server. We publish a full list in the guide documentation. ArcPy is included within the local server deployment. You can use extra site packages to extend the out-of-the-box functionality like I did with the fantasy maps generator. You need to install those packages to ArcMap first for your development and your packaging of the geoprocessing tool. And for local server 100, you should be working with ArcMap 10.4.1. You need to enable geoprocessing and Python in the deployment manifest when you're building your application to ensure that the right libraries for local server are deployed. And then ultimately, like I showed in the solution window, you need to copy those Python packages into your local server deployment. So some of the things that I didn't have time to show today were debugging tips for local server. So within the local server SDK install, which goes into your program files, ArcGIS SDKs folder, there's actually a local server utility application, and that is a UI onto a JSON config file on disk, and it sets a number of properties that help you debug and work out any issues that you might be having executing your Python scripts within local server. So if you're in the realms of custom Python scripts and additional site packages like I was here, then it's actually really useful to enable some of these options. One, to perhaps enable the logging so you can see if the service actually crashes in some cases because it couldn't access some resources that are available. Then you can get the log file and take a look at the contents of the log file. You can also run an application like Fiddler to capture the HTTP traffic and monitor that and see that the requests going out and the responses coming back are good. And then also, for security reasons, we actually add a random prefix onto the URL of the local server every time it starts up, which means that the local server URL is never the same. Applications outside of yours can't predict what that local server URL will be. but you can disable that, which helps you with debugging. So it's a predictable URL every time. Every time the service starts up, you know the URL is the same. And if you check the option to generate HTML server pages, just like with ArcGIS Server, then you can execute these geoprocessing services via a browser, and you can just submit that without having to actually run any code at that point. You can paste in snippets of JSON, geometries, and attributes, and things as your inputs. So it really helps you interact with the service, figure out what's going on without having to actually write a full application to go all the way through the process. So the 4 tips there would be enable logging, use HTTP traffic monitoring, disable the random prefix, and also generate HTML pages as well. So thank you for joining me in Livin Vida Local Server. We have a couple of minutes for questions now, otherwise I'll be available on the showcase afterwards. There's one there. Okay, so the question was, what license do you need to use local server? So it might require 1 or more licenses. The minimum license you would need to use local server is a standard license. I was also using a 3D analyst tool there called Interpolate Shape. So that would need the analysis extension for local server. So you would need a standard license with the analysis extension. There is also an advanced license, so that unlocks some additional geoprocessing tools, and analysis works at both standard and advanced level. Okay, no more questions, then thank you very much for attending today.